While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home as it will hopefully enhance your mathematical understanding. So welcome back to 1 Lesson 3 Math. This video includes an IGCSE Maths question on linear graphs. So if you'd like to have a go at Part A, Part B and Part C, please pause the video now before I proceed with the solutions. So there's a nice graph, 3y plus 2x equals 8, and this is line L. We need to find the gradient and the y-intercept. So the first thing we're going to do is we're going to think, right, to find the gradient and to find the y-intercept, we need to set up that equation in the form y equals mx plus c. So we need to rearrange. We need to have it so that it's y equals. So the first thing we're going to do is we're going to move the 2x, the positive 2x, to the other side. And to do that, we're going to minus 2x from both sides. So the second line of working out is 3y minus 2x plus 8. And you'll note that I've put the minus 2x where the mx goes, so that it's in the order of y equals mx plus c. So I've got 3y equals minus 2x plus 8. So then I'm going to divide by 3, because I need to get it so that it's y equals. So if I divide by 3 throughout, 3y divided by 3 is just y, equals minus 2x divided by 3 is minus 2/3 x. And then we've got 8 divided by 3, which is plus 8 over 3. I'm leaving it with a denominator of 3 as a top-heavy fraction at the moment. So then I can say that the gradient is minus 2/3, because that's the number on the x. Now the intercept is always 0 and the c. So it's going to be 0 and 8 over 3. But that can also be written as 0, 2 and 2/3. So that would be the gradient and the y-intercept. Again, just rearranging the equation, putting it in the form y equals mx plus c, and then you can read off those values. Minus 2/3 for the gradient, 8 over 3, or 2 and 2/3 for the intercept as the y-coordinate with the x-coordinate as 0. 0 and 8 over 3. So, we can move on to part B now. Line P passes through the point 2 and 10, and it's perpendicular to line L. Show that the equation of line P is 2y minus 3x plus 14. Now, what we're going to have to do is we're going to have to look at a perpendicular gradient. Now, a perpendicular gradient is minus 1 over m, and it's using the m of the other line. So if the gradient of the other line is minus 2/3, the perpendicular gradient here is going to be minus 1 over minus 2/3. Now that becomes 3 over 2, because the denominator of the denominator comes to the top to be the numerator, and the denominator 2 will remain. The minuses cancel out because a negative divided by a negative is a positive. Now, I'm going to put a little note here because that's not the easiest thing to comprehend. What I've done there is I've done, getting rid of the negatives first of all, I've got 1 divided by 2/3. And I stay switch flip. And that becomes 1 stays, the divide switches to a times, and I flip the second fraction. So that becomes 1 times 3 over 2. That's 3 over 2, and that's 1.5. So 1.5 is probably a little bit easier to use, and therefore I can start to write the equation in the form y equals mx plus c for the perpendicular graph. So because I've worked out the gradient to be 1.5, I can now substitute in the point x equals 2, y equals 10, and that'll allow me to work out the c. So if I sub in 2 and 10, the y becomes 10, it becomes 1.5 times 2 plus c. So 10 equals 3 plus c, and therefore c is going to equal 7. So I can put that into the equation now. Y equals 1.5x plus 7. Then I need to do a bit of rearranging so it's the same as the equation in the question. If I've got y equals 1.5x plus 7, I can times everything by 2. So I've got 2y equals 3x plus 14. As you can see on question B, it's minus 3x. So I'm going to bring the 3x to the other side by taking it away from both sides. So then I've got 2y minus 3x equals 14. And you've now shown that the equation of line P is 2y minus 3x equals 14. On to part C. Now what I've got now is two equations with y and x unknown. This is how I'm going to find the coordinates, and they are simultaneous equations. For simultaneous equations, I say make the y's move. Now the y's are at the front, which is a little bit different, but we can still apply the same logic. We need to make the lowest common multiple of the y's. 3 and 2 is 6, so I'm going to times the first equation by 2. I'm going to times the second equation by 3. So the first equation times by 2 is 6y plus 4x equals 16. I've times throughout by 2. The second equation, I'm going to times it by 3, and that gives me 6y minus 9x equals 42. I've times throughout by 3. Now, at this point, I always ask the question, is it the same signs takeaway? Now, on the 6y's, they're both positive, so yes, it is the same signs takeaway. So I'm going to take away those equations. But I've got to be careful, because once I've eliminated the y's, I've got 4x minus minus 9x. Minus minus becomes a plus, so that becomes 13x. 16 take away 42 is going to be negative, it's minus 26. So then I divide by 13 and I get x equals minus 2. Now I can substitute that into any of the equations. I'm going to go back to the first one. 3y plus 2x equals 8. So 2x is going to be minus 4. So that's going to be 3y minus 4 equals 8. Add the 4 to both sides. I've got 3y equals 12. Divide by 3, I get y equals 4. So now I've got the x and the y values. I can write that as coordinates, minus 2 and 4. And that's the coordinates where line L and line P intersect. So I hope that's been a useful tutorial. Pasta la pizza, arrivederci, so long, goodbye, au revoir, auf Wiedersehen, ciao for now. See you next time.